Hi guys, I'm going to set up these last three problems for you. I think that you can do the equations once they're set up, but let's go ahead and set up number 4 and 5. So a chemist mixed 12 liters of a solution that is 45% acid with 8 liters of a solution that's 70% acid. What is the percent of acid of the mixture? So we're going to look first at the initial solutions. So let's just do solution 1 and solution 2 because they're not labeled. And then we're going to look at the mixture and what we want that total to be. So this last row is generally going to be the total, or what we want everything to finally mix out to be. So solution 1 is 12 liters. That is 45% acid. Remember, we're going to put that in a decimal. Gives us 45. Solution 2 is 8 liters at 70%. And we want our total amount to be what percent of acid mixture? Well, it looks like we don't know any of this. Okay, so that's what we're going to have to figure out here. All right, well, there are some clues here. If this is our total, and this is 12 liters, and this is 8 liters, and we're going to be adding them, well, we add that up, and that's 20 liters. Okay, does that make sense to you? The total amount is going to be the 12 liters added to the 8 liters. And we don't know what that percent of acid is going to be, so we're just going to make that x. So if we take 12 and we multiply it by 45 hundredths, we get 5 and 4 tenths. So that's going to be that percent. And then our second solution is going to be 8 liters at 70%. And that's going to give us 5.6 liters. So if we take that and we're going to add these two and get 20x, we get 5 and 4 tenths plus 5 and 6 tenths equals 20x. And then we're going to add those two, so we're going to get that 11 equals 20x, divide by 20, divide by 20. 11 divided by 20 is going to give you x equals 55 hundredths. And if we're going to turn that back into a percent, then we're going to multiply that by 100. We get that x equals 55%. So that means our combined solution, and it makes sense if you look at it. This one's a little bit less, this one's a little bit more, so we know that our mixture is going to be right in between, and it turns out perfectly at 55%. Okay, the last one, well, it doesn't always have to be a mixture of solutions or liquids. This one is a grocer mixes 5 pounds of egg noodles costing 80 cents per pound with 2 pounds of spinach noodles costing $1.50 a pound. What will the cost per pound be of the mixture? So let's look at egg noodles and spinach noodles. Okay, we have 5 pounds of egg noodles at 80 cents and 2 pounds of spinach noodles at $1.50. And we want to add that to find out what the cost per pound is going to be. So that's our unknown. That's our cost per pound. So this is our mixture. So we have 7, and our price per pound, we don't know. But we know that it's going to add up to be 7x. So 5 times 80 cents gives us 4. And 2 times 1.5 is 3. Well, look at that. We're going to have that 4. So we're going to add these two to get our total. 4 plus 3 equals 7x. 7 equals 7x. Divide by 7, x equals 1. And what are they asking us? The mixture, the price per pound, needs to be right in between. And if we look at this, it makes sense. We have more of the 80 cents than we do of the $1.50. So our price is going to be closer to 80 cents. I want you guys to really start looking at these and going, okay, this makes sense. It's going to be closer to 80 cents than to $1.50 because there's 5 pounds of this one and only 2 pounds of this one. So there's going to be just 1 pound of the mixture. Oh, excuse me, $1 for the mixture. Sorry about that. I wasn't labeling that correctly. $1 of the mixture. This is logical reasoning, and I want you guys to see this is not just random math, but logical reasoning. So make sure you have those 2 problems in your notes for Thursday or for Friday.